Modern CPUs and the compilers reorder instructions for better performance. They also keep the values in the CPU cache, which may not be updated in the RAM memory, which causes the issues in some cases. So for example, issues like a race condition that we have seen before, visibility issue, or the atomicity issue, all these may happen in the multi-threading environment. So what happens is that in Java, we have the Java memory model, which basically is the set of the rules, and one of them is the happen before relationships. It ensures that the visibility and the ordering operations across thread. So what's that exactly mean? So let's go step by step and understand. The first one is that the program order rule, right? So what program order rule says is within the single thread, statements appear to run in order. So for example, let's go here and see that what exactly it means. So in this example, we have in the main thread, we have two variables, A and the B. A, we are setting value to 10, and in the B, we are setting the value of A plus 10. So we expect that when we write this program, right, we expect that the value will be printed, A will be printed 10, and the B will be printed 15. So what Java memory model does is it ensures that this one writing to A will happen exactly, the order will happen exactly the way that we put that, right? Imagine that the CPU has reordered that. So what will happen in that case is that we, for the B, we will get the value of 5, which is not expected for us, right? Which may create a confusion and basically may create unexpected result in our program. That's the first rule that defined in the happens before. What's the next one? The next one is that the monitor lock rule, right, in the synchronized. So we have seen that before in the previous episode, but let's go over it one more time. So as the rule goes, unlocking a monitor happens before another thread locks it. So what exactly that means? So let's go and see another example of synchronized. So here what we have is we have a counter class, and if we go here we have a field count, right? In the count, so what we do is we are counting. So we have two methods, increment and the get. So increment and the get. So in the increment we are incrementing the count, and in the get we are getting the whatever the count value is right here. So as we have seen in the previous episode, this operation increment, right? It's not just increment, it's divided into 3 steps, right? The first step is we are reading the value from the RAM memory. In the second, we are in the CPU register, we are incrementing that value, and in the third, we are writing that back to the RAM memory. So we want to make sure that the releasing the lock, right? And by default, every thread is creating a monitor or a lock. And when we are put the synchronized keyword, right, in the method, so access to that monitor or access to that lock, the key to that lock can be only obtained by one thread. So what we make sure is that the lock, happens, this operation, right, this whole operation happens before the releasing lock. So basically we release the whole operation, and only after that we release the key, and we are releasing the lock for this operation. And that's the first part. And the second one is that here, right, for the get count, so we make sure that this happens after we are acquiring the lock. So what will happen that if we releasing the before lock, so which means that this operation may not be atomic. That's the first problem. And also if we acquire the lock, if we are acquiring the lock before, so if this operation happens before acquiring the lock, so we may get result here, the result that we get here, it may not be the latest result, right? So that's the second rule that we are defining in the Java memory model. Let's go to the third one. What's the third one? The third one is that the volatile variable rule, right? So as it goes that the volatile variable rule, write to a volatile happens before a subsequent read. Let's go and see this example. Let's take a look at this example. So here what we have two threads, the thread writer, so the thread writer does is it sets the value to the number, which is a global variable, to 42, and it sets the value to true for a, again, global variable, which is the ready. So ready is the volatile. So what it means is the changes that is made to this variable, it will be seen by all other threads, right, in our program. So, and we want to make sure that the read of this variable ready, it will be, so write to that will happen where it happens before the read, right? The happens before rule here is that it happens before the read. So otherwise, this will read will see that the old value of the ready, and it will not go further, right? It will not print the result here. So that's the first one. And another one is that we have number here, which is not the volatile, right? But here, if we set the value to true, so whatever the value comes before it, whatever the variable comes before the ready, those variables also will be flashed to the RAM memory. So for example, in this case, if we print the number here, right? If we print the number will give us 42. Let's run and make sure that it works as expected. Yes, you can see here the number is 42, because in this case, that it's not that it will happen before, it happens before the read. That's the first one. Also, all variables that come before this variable that is volatile, they also will be flashed to the RAM memory. So that's the rule for the volatile. Now let's go to the next rule. The next rule is that the thread start rule, right? Thread start happens before actions in that thread. So let's go and see the example of the thread start. So what we have here, we are in our main method, we have one variable, data, let's say, right? It's a global variable, and we are setting that value to 42. So we make sure that it happens before the thread start. So, right? So setting the value to the 42, it happens before we are starting this thread. So otherwise, what's going to happen is we will see the value here 0, right? But we want to, because when we write this program, we expect that the value here will be 42 because we already set that here to 42. That's why it happens before the thread start. So let's run this, and as we can see here, the value is 42, and the Java memory model makes sure that the happens before rule also works here. So now let's go to the next one. Next one is that the thread join rule, right? Thread join rule is the all action in a thread happens before another thread returns from join. So let's go and see exactly what does that mean. So let's, for example, in this case, we are creating a thread and we are setting the result to the 99, and 99 is a global variable, so we are setting the value of value for this variable result to 99, and we make sure that this happens before the join, right? So because here when we print the result, we expect that this thread already will finalize its work, and will set that to 99, and we will see here the value of the 99. So let's run it, and as you can see here, main thread sees the result of 99. So again, this one, right, this one happens before this join statement, which means that before this thread finishes its work. So let's go to the next one. Next one is that and now our final rule, which is that the final field rule. So final field rule, it's a write to a final field in a construction happens before reference is published. So let's go and see. So for example, here we have created a config. So let's go to the config and let's see what we have here, right? We have one field, it's a final, and we are setting that value to 100. This one happens before publishing the reference to this variable, right? So what it means is here, right, in the writer thread, if we are creating a config, and here we are creating one config, and we are creating one config here, a new config, right? And when we are printing this value, we make sure that this one, right, this setting the value to the final, it happens before publishing the reference. So here we are publishing the reference so here we have the reference to that field, to the size. We make sure that this happens. setting the value happens before we are having a reference to that field. And that's for the write. And for the reader, we again, so we here, right, we already have the reference to that size in the config class. So let's run it and let's see that it works exactly as we expect it to work. Again, reader config size is 100 and the config created with the size of 100. So that's it. That's all the rules. It's not the complete list, but it's the main rules that we have for the Java memory model. It's again, Java memory model it makes sure that when we write a program, because when we write a program, we have certain expectations, right? We expect that certain rules for the locking and the unlocking. So we have certain rules for the visibility. We have certain rules for the thread start, for the thread join, for the final field. Without Java memory model, the CPU and the compiler, it just will optimize the code and we may get the unexpected results.